Alrighty guys, hey, I know that intro was a little cheesy, but hey, we talking about right triangles today. Come on, some right triangles. We talking about some trig. We talking about some sine, cosine, tangent, all the good stuff. Unit circle, even as a little bonus, okay? So we ain't talking about isosceles, we ain't talking about scaling, we talking about some right triangles, all right? So tune in, let's go. Alrighty guys, hey, welcome back to Mullet Math. We're gonna go over right triangles today and how that kind of relates to the unit circle. So let's just dive on in here. Number one for theory, biggest thing that I wanna point out today, if you don't know SOHCAHTOA, you need to learn it right now, okay? Go back to your geometry notes, find some other YouTube videos, but really dive into SOHCAHTOA and remember what those mean. I have it written down here, what the sine, cosine, and tangent functions are for SOHCAHTOA, but remember, quick review, SO is sine, opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent, T, is opposite over adjacent, right? So that's how we remember SOHCAHTOA. Repeat that in your brain. Like I said, really drill that in, because later on, if you're going into engineering, if you're going into advanced math, computer science, something like that, you are going to use this on a daily basis. Even if you don't go into anything like that and you're even in just the construction world or the trade world, you will be using this 24/7, and I will prove that on later on here. But with that being said, drill that into your mind so that you can remember for the future. And it's better to learn it right now rather than later, right? So one of the first common triangles I have written out here is our 30, 60, 90 triangle, okay? That's gonna be used all the time in the unit circle. So this one's super important to learn and memorize what these values are here, okay? So we have our adjacent side. This is just kind of our basic 30, 60, 90 triangle. And our adjacent side here from the 30-degree angle is gonna be the square root of 3, okay? Our opposite side, right? Our opposite side of this 30-degree angle, it's always going to be, if you draw a line going to the opposite side, it's going to be a value of 1. And our hypotenuse, obviously, is the longest side. And it's also what a squared plus b squared equals, right? That's kind of how we get to this hypotenuse value. And I wrote that down here just to kind of clarify what we're doing, right? We're doing just the Pythagorean theorem, right? A squared plus b squared equals c squared, right? You come down here, square root of 3 squared plus 1 squared equals 4. You take the square root of that, you get 2. That's our hypotenuse, right? Same thing over here with our 45, 45, 90 triangle, okay? You take a squared plus b squared equals c squared. Well, a and b equal 1, so you square those, take the root of it, and you get the square root of 2 for your hypotenuse, okay? Hopefully that's pretty simple for everyone. That's algebra and geometry kind of review, quick review. Well, let's kind of dive on into the special functions of these triangles and the special values of them, okay? So if we want to find the sine of 30 degrees here, okay, we are going to remember SOHCAHTOA, right? So the sine of 30 degrees is just opposite over hypotenuse, okay? So it's going to be our opposite side here, 1, over our hypotenuse, 2, okay? So let's write that out. We have our value of 1 over 2, which is just half, okay? So that's nice and pretty. We'll move on to the next one here. Well, our cosine of 30 degrees, we're going to take adjacent over hypotenuse, right? So cosine of 30 is adjacent square root of 3 over the hypotenuse too, okay? So that one's pretty simple too. So we just have square root of 3 over 2, okay? That's our value there. Now if we run down to tangent of 30, this one gets a little tricky, in my opinion, because now you're using the opposite over adjacent. And the biggest thing is just to remember what our opposite side is versus our adjacent side. That's why I wrote the O and the A out. Just always remember that. So it's super easy for me to remember the opposite is opposite of the angle we're looking at, okay? So our tangent of 30 degrees is opposite over adjacent. Well, if we write this out, we never want to leave a square root on the denominator, right? That's never good looking. So we're just going to multiply this by square root of 3 over square root of 3, right? This just equals 1. So that's pretty simple, but now we can rewrite this as the square root of 3 over 3, right? Because the square root of 3 multiplied by the square root of 3 equals 3, okay? So that's our most simple answer here, simplified out. So what did we just figure out? We figured out that the sine of 30 is half, the cosine of 30 is square root of 3 over 2, and the tangent of 30 degrees equals root 3 over 3, okay? Moving on to our 60-degree angle here. This one's also very useful to know, and I'll explain that why here in a little bit. But let's kind of go over the values of the sine of 60, okay? Well, now I wrote this O, A, and H to the 30-degree angle. But now remember, now we're looking at the 60-degree angle. So the adjacent side is now your opposite side from 60 degrees, okay? So now we're kind of jumbling this up, but here we go. We're gonna go sine of 60 degrees. We have opposite, which is root 3, divided by hypotenuse 2, right? So we're just gonna write that out, root 3 over 2. And we're gonna leave that like that because now our root is on the numerator and we're okay leaving it that way. We just never want the numerator, or excuse me, a root on the denominator, okay? So moving on to cosine of 60 degrees. Now we're gonna have our adjacent side of 60 degrees. This angle is now what used to be our opposite, okay? Which equals 1 over h, which we've already seen that, but that's 1/2, okay? And so now our tangent, same thing. Now we have opposite over adjacent, right? Opposite of 60 is root 3 here over the adjacent, which is 1. So anything over 1 is just itself, right? So we're just gonna write out root 3, okay? Well, let's kind of make some connections here because as much as we could memorize this triangle, I find it kind of easier to memorize what's going on down here, okay? So for this 30, 60, 90-degree triangle, let's note something, okay? So the sine of 30 is half. That's a pretty easy value to remember. But also down here, the cosine of 60 equals half, okay? So these two terms are alike, okay? I'm gonna just put a star by them. Okay, well, let's also look at the cosine of 30, okay? Cosine of 30 is root 3 over 2. Well, if we come down here, what do we have? Well, we have root 3 over 2. So these ones are similar. I'm going to just give it a triangle here to kind of show you that these are related, okay? And if we have our tangent now, they're a little bit different, but we can still kind of see tangent of 30 degrees is root 3 over 3. Okay, so tangent of 30, there's a lot of 3's here. That's how I remember this. So tangent of 30 is square root of 3 over 3. Okay, and it is kind of related to tangent of 60, but tangent of 60 is just root 3. Okay, so if it helps you out, this is kind of the way I remember it. Tangent of 30, there's more 3's, so that we know that it's root 3 divided by 3. Okay, and we come down here to tangent, and it's just going to be root 3. Okay, so let's come on over here to our 45, 45, 90-degree triangle, okay? And this one's way easier because we only have sine, cosine, and tangent, right? They're the same angle on both sides, so we're not gonna really have a different 45-degree angle, right? They're gonna be the same. So, well, what is the sine of 45 degrees, okay? Well, it's opposite over hypotenuse, right? That's what we're saying here, opposite over hypotenuse. So the sine of 45 degrees, right here for this angle, well, it's gonna be 1 divided by root 2, but remember, we don't want to ever leave a root 2 in the denominator, so we're going to multiply this by root 2 over root 2, which now we're left with root 2 on top, and we have 2 on the bottom, okay? So we're going to write this sine of 45 as root 2 of over 2, okay? We're going to move on to cosine here, so same angle, cosine of 45. It's going to be adjacent over hypotenuse. Well, isn't that the same thing as what we just did, right? We have 1 over square root of 2. Well, this side, a, is equal to 1. So now we're just going to have 1 over root 2, which we did here, and we're going to multiply it by root 2 over root 2. So that's just going to give us the same value here. So we can really just skip this process. We're doing the same thing, and we're going to have the same value, root 2 over 2, okay? And now if we have tangent, this one's kind of fun. If we have tangent of 45 degrees, we have opposite over adjacent. Well, because our values are 1 over 1, right? I can write this out. It's just going to be 1 over 1, which equals 1. Pretty simple, okay? So the way that I like to remember this is if we look over here at the 30, 60, 90 triangle, is if we have sine of 30, well, the cosine of 60, so the opposite, is going to be equivalent in values, okay? This is just the way that I like to think about it. Hopefully this is the simplest way, but if we take sine of 30 equals half, well, then we know that the cosine of 60 is going to be half as well. And if we take the cosine of 30 as root 3 over 2, then we know that the sine of 60 degrees is going to be root 3 over 2 as well, okay? And like I said, the tangents kind of get tricky. But if we just cover this up, right, and we remember sine 30 equals half, and cosine 30 equals root 3 over 2, then I can say this again as cosine of 60 equals half, and the sine of 60 equals root 3 over 2. Do you see what I'm doing there with the opposites? So that's kind of the relationship between sine and cosine for these 30. But then when we come over here to the 45, 45, 90, it just is simply root 2 over 2. So that's pretty easy to remember for sine and cosine, except for tangent, right? Tangent is different, it's 1. So remember the tangents are kind of always the oddballs, but for the other ones, hopefully that is a very easy way. And like I said, I'll put a square here to kind of show that these are the same value, but hopefully that's an easy way for your mind to kind of group those. That's the way at least I think about it. Okay, so that's the theory. So let's kind of look at the unit circle here. Alrighty guys, so now we're looking at the unit circle, and what we're looking at here is kind of the relationships we developed over here between these right triangles and what we have going on at the unit circle. So in a previous video about radians and degrees, I kind of went over the basics of the unit circle, right? And the fact that the radius of a unit circle is 1, right? It is split up 0 degrees to 180 degrees. We're also given radians here, right? 0 radians all the way to pi radians, that equals 180 degrees. And we kind of went over the relationship there. So we have our degrees, we have our radians, but out here on the outer shell of the unit circle, we have all of these values. And hopefully you're kind of starting to see the pattern between these two, right? If we come to our 30, 60, 90 triangle, okay, let's look at what we have here, okay? We have root 3 over 2, and then we have half, right? So root 3 over 2 is our x value, and I'll write that out real quick, x, and we have a y value, okay? So that's how we should always be looking at those. So if we look at our 30, 60, 90 triangle, well, let's see what's going on here. Okay, well, we have root 3 over 2, root 3 over 2. Okay, so we have a relationship there. And we're looking at the y value now. If we look at our 30, 60, 90 triangle, well, what is half? We have sine over here of half. So we have a 30-degree angle. So we know that we're going to be looking up here at our sine, cosine, or tangent. Okay, but we know that for cosines and sine, cosine has to do with an adjacent side, right? So this kind of makes sense over here, because if we're saying that our x value, if we drop a line down right here, which I'm going to do, all the way to 2 pi, pretend it comes to the x-axis here. Actually, I'll drop it down, why not? So we're coming down here. Well, this x side, right, out here, is going to equal that cosine side, right? That adjacent side. That's what this x value is that adjacent side, right? So what we're saying here is our adjacent side, x, is equal to cosine of 30, which is root 3 over 2. And looky here, that's what we have written, right? Hopefully that makes sense. Now we're going to look at our opposite side of this 30-degree angle, right? This is our angle here. And we have the opposite side is y. And we're saying that this y value on the y-axis is equal to half. Well, what did we find over here that equals to half? We found sine of 30. And why does that make sense? Well, it's because the sine, so SOHCAHTOA, so opposite over hypotenuse. Well, remember, the hypotenuse of the unit circle is always going to be 1, right? So it's all of these values just over 1. That's why the unit circle is so beautiful, because whatever our hypotenuse is here, it's just the radius of the circle. Do you see that, right? The radius of the circle, no matter where you are, is a value of 1, okay? So if we have all these values over 1, this is super simple and easy to remember when we come over here, okay? So let's kind of do one together here. What do we have here, okay? Well, we have a 45-degree angle, right? We know that there's going to be a sine and cosine. We know that those are the exact same values. So our x and y coordinates out here listed on the outside of the circle for this, well, our cosine, our x value, if we drop it down to the x-axis, is just going to be root 2 over 2, right? That's what we have, cosine of 45. Okay, that's root 2 over 2. So that's our x value, right? We drop down. But now our y value here on the outside is going to be sine of 45. Well, sine and cosine of 45, luckily, are the same exact value, right? Root 2 over 2. So our x and y coordinates, from what we just said, if we uncover those, it makes sense that it's root 2 over 2, root 2 over 2, right? So the last one I'm going to point out here is that we have our 60-degree angle here, right? we come down here to our sine of 60 and our cosine of 60, kind of what we found earlier. And I'm going to just drop this down again, right? And we're still looking for an x value here. Now we're looking for this value from the center of the circle, of the unit circle, to here, right? And then our sine is going to be our opposite value here, which is still our y. Okay, that's our y value. So we have our x value, which is going to be cosine, we know that. And we have our y value, which is going to be sine. Well, if I cover this up, let's pretend like we don't know what this value is, okay? And I said, well, we know that the cosine, like we talked about earlier, cosine of 30 is root 3 over 2. Well, then I know that the sine of 60, right, the opposite, is going to be root 3 over 2. And then we're just going to flip-flop it, right? We're going to say our x value here on the x-axis is going to be half. Well, let's see if that's true. Well, yep, our x value is half, right? We're coming here at half. And then we're going up our y value to root 3 over 2. So it all works out, right? So hopefully that kind of clarifies that. And we can do that for the rest of all these angles all the way throughout the unit circle. But just remember, all you're working with is two 30, 60, 90 triangles. Hopefully you kind of see what we're doing there. We have our 30, 60 here and our 30, 60 here, and then a 45, 45, which is going to be the same values no matter where we're at on the unit circle, right? So it's super easy. You just have to remember what quadrant you're on, right? So let's kind of talk about that real quick. Our quadrants, we're going to be positive over here, right, for our x's. We're going to be negative over here for our x's. And we're going to be negative here for our y's, right, -1, and positive here. So if you're in this quadrant over here, we're going to be positive, positive, okay? A lot of teachers will talk about this. If we're over here, our x value is negative, but our y value is still positive because we're going up in the y direction, right? So it's going to be negative, positive. That's what we see here, a whole bunch of negative values and then positives, okay? Well, if we come down here, this is the area you don't want to be in, right? Because it's what? Negative, negative. We don't want two negatives. We always want to be kind of positive at some point. But let's say we come over here into our fourth quadrant. Our x values, we're coming in the positive direction, but our y values are negative. So over here, it's going to be positive, negative. So hopefully you kind of get a better understanding of what this unit circle is really saying and kind of the relationships and the easy ways to remember what we're doing here. Because I would argue if you can get through this first quadrant here and you remember this is 1, 0, this is 0, 1, and then you remember how to get these x's and y's right here, just based on the 1, 2, 3 values that you have to remember, well, you can do the rest of the unit circle, right? It's just changing whether it's a negative or positive, right? All of these are kind of the same number. You just kind of have to remember that relationship. Okay, alrighty guys. So moving into number 2 here, our conceptual part of this unit. Kind of not focusing anymore on the unit circle, but moving into more of the actual concepts of sine and cosine and why they're so powerful. Okay, so let's talk about that. So we have a triangle here with an unknown angle here. It's just theta. And we have our x-axis and our y-axis. And the easiest way to represent an x value and a y value here, right, our y direction and our x value here in our x direction, is just by having a given length, okay? And that's what I really want to drill into your head is that A here, no matter what value L is, our hypotenuse, we can calculate the corresponding x and y values, right, x and y, just based on their trigonometric relationships. And all that's saying in fancy terms is we can literally say for a given that for a fact that we know our x and y value just based on being given a theta and a hypotenuse or a length, okay? That's super critical and super important to understand. We always will just say the adjacent side here is just our length times cosine of theta, and that's gonna be our x value, and our opposite side of the angle is just gonna be our length times sine of theta, this angle right here. That's just gonna be our y value, right? That's super critical to understand. And conversely here, at point B, we can find any length L with only one known side length. We can have an x or a y, and a given angle, right, our theta. So let's say we're given a theta and one of these sides, well, we can find an L, or we could even find the other side. It's just super important to know that only given two pieces of information, we can find everything else out about the rest of the triangle, okay? And that's super important moving on and being able to know that as we move forward in math, okay? Well, let's move on to point C here. It's a little bit different, but I kind of want to get your mind churning a little bit, and I want you to see the relationship here, okay? So my point C here is L is just a scalar, right? We're talking about the same L here, but L, the length of the hypotenuse, is just a scalar for any circle with a radius of L, okay? So up here we just see a triangle, okay? But what I want to kind of trick your mind and let you see down here, or encourage you to see down here, is we have a circle, okay? Let's say this length right here, or the radius of the circle, is L1. That's just going to be 1, okay? Well, let's say we have a bigger circle here, and let's say this is our big circle, right? And our radius here is 1 plus 1, which is 2. Okay, so we're saying that the radius of this circle is 2, and the radius of this one is 1. Okay, well, let's say we wanted to find an x1 here. We're going to drop a line down to the x-axis, and we want to find these values here. Well, we can find those just like we talked about up here, right? x1 here, our x1 value of the little circle, is just going to be 1, because that's our radius, right? Or our L value, 1, times the cosine of whatever that angle is. Okay, and our x2 is going to be radius 2, so length 2, times cosine of theta, right? These are going to be the x values down here. And I just wanted to kind of show you this because hopefully it's starting to click that, well, our unit circle is 1, so that's beautiful. We just know that it's cosine of theta, whatever that value is, right? That's kind of what we were talking about here. When we were talking about the unit circle, we're just finding cosine and sine. And remember, we were talking about how we divided it by 1, but it's super simple because it's just the unit circle, so it's just 1, right? Well, that's kind of what we're showing right here. But then we also have this x2, and we're scaling it by another factor of 1, right? So the radius is 2. We're scaling it. It's a bigger circle. It's now 2. So now it's just 2 times cosine theta. That's this x-axis, or the cosine value down here. Now, why is that important? It's really important because this 2 could be any number. What we're pointing out here is that the length of this radius, or the length of this triangle, if it's a circle or just a straight triangle, it will always just be a scaling factor. Okay, so, and that's super important because you can take a measurement in the real world here, and if you know the angle between that and the x-axis, or this straight line here, right, you can find that value just based on this being a scalar, right? So 2 times cosine of theta. That's why this is so powerful to know and to be able to use in the real world, okay? So with that being said, let's move into number 3 here about solving, okay? So example 1, we want to find the value of x and y. Okay, so this is a 2-part problem. First, we want to find the value of x here. Well, going back to SOHCAHTOA, it's kind of important to know what we're going to use. We don't really care about this angle, but using, I believe, the cosine of this angle, it's going to be easy to find x, right? Because the cosine of 32 is the adjacent side, which is this x value, over the hypotenuse, right? That's the ka. So we're going to come over here and do ka, right? Cosine. So cosine of 32 degrees, okay, is going to equal adjacent, right? X over 1.75. Well, this is pretty easy algebra. We can just multiply each side by 1.75, right? And we can bring this over here. And then we're going to have that equal x, okay? So we have 1.75 times cosine of 32 degrees. And that is going to equal x, okay? So what does x equal? X equals this typed out. But now, be careful, guys. When we're using our calculator, I kind of talked about this in my last video too, but make sure that we're in degree mode or radian mode based on what this angle is being given off of, right? So we're using degrees, okay, so I'll quit out of that. And we're going to do 1.75 times cosine, okay, of 32 degrees. And that's going to give us x equals 1.48 units. We don't know what the units are. We just know that that's our value, okay? So that was pretty easy, right? Pretty simple, just using cosine. But now we got to find y. That's the second part, okay? So just remember, the opposite side is the side that we're trying to find. So that's that y value. So we're going to use sine, right? Or so, excuse me. So the sine of 32 degrees equals our y value. So O opposite over hypotenuse, 1.75. Okay, and we're going to do the same exact thing. It's the same relationship. We're going to bring 1.75 over here, but now we're going to multiply it by sine of 32 because we're using so, right? So 1.75, excuse me, times sine of 32 degrees is going to be our y value, okay? So y, therefore, equals, well, 1.75 times sine of 32 degrees equals 0.9. We're going to round up to 3 units, okay? So we just solved that pretty fast, pretty quick. Hopefully all those steps made sense. Not too complicated using our cosine and sine functions. But let's move on to example number 2 here, okay? Well, now we're being asked to find the value of y and L, but I kind of wrote this triangle in a different way to try to kind of stump you, okay? So let's kind of take a peek at it. Well, we know we have our angle here, 44 degrees, that's given. And we have a side length here of 5, okay? And we have our hypotenuse L, and then this y value down here. But keep in mind, this y value, if we're talking about this angle, is the opposite, okay? So up here, how we were doing cosine, that's because the adjacent side is the adjacent side to this angle. Well, down here, we're going away from the angle, okay? So it's the opposite side. So we're going to use sine if we want to find this y value. Or we could even use tangent, which here we don't want to use sine because we don't have a value of L given. Okay, so this is why we'd want to use tangent, because we have a angle given, that's one value. We have an opposite side that's not given, but we have an adjacent side that is given, okay? So hopefully you understand my reasoning for choosing tangent TOA, opposite over adjacent, okay? So we're going to write tangent of 44 degrees. Okay, that's our angle, equals the opposite side y over the adjacent side 5. Okay, that's the adjacent side to this one, all right? Well, it's kind of the same operation as we did up here. This is just, we're going to multiply each side by 5, right? 5 times tangent of 44 degrees equals our y value. So y equals, let's do it on the calculator here, 5 times tangent 44. It's going to be 4.83 rounded up units, okay? That's our final answer there. And now we want to find L. Well, there's a lot of different things we can use here. We could technically, if we wanted to, use the Pythagorean theorem, because now we have our y value and we have our x value. So we could do a squared plus b squared equals c squared. But for the sake of our lesson here, let's keep practicing our SOHCAHTOA, right? I'm going to use cosine, okay? So I'm just going to arbitrarily choose cosine. So it's going to be ca, right? So cosine of 44 degrees is going to equal the adjacent, right, 5, divided by L here, okay? Or hypotenuse, excuse me. So adjacent over hypotenuse is ca. Okay, well, this one's going to be a little trickier. We have to get L by itself, okay? So algebraically, we're going to multiply each side by L. So L is going to come over here. But then we need to get rid of cosine 44 because we want to get L by itself. So let's write this out. L times cosine of 44 degrees equals 5 because we multiplied each side by L, excuse me. But now we want to divide each side by cosine of 44 degrees to get L by itself, right? You see what I'm doing here? Okay, so L equals 5 divided by cosine 44 degrees, okay? And this simply gives us down here, if we type this into our calculator, 5 divided by cosine of 44 degrees, we're going to get 6.95 units, right? So our L value in this triangle, our hypotenuse, is going to be 6.95 units. And our Y value here on this side is going to be 4.83 units. And we just use tangent and cosine to find that, okay? Alrighty, guys. So moving into number 4 here, our real world application, okay? Well, we have a plumber that needs to find the length that a pipe needs to be to maintain 9 degrees of slope over the span of 500 yards, okay? So we have our little plumber here. He's got a little mullet. He's standing here. Well, over 500 yards, let's say this is a building that's 500 yards long. We know it's 500 yards long, okay? And we know that our pipe here, this is the pipe in blue, it's going down into the ground at 9 degrees, okay? So the plumber needs to maintain this 9-degree slope all the way for 500 yards. Well, how much pipe does he need, right? That's what we're actually finding out here, right? The plumber needs to know the length that the pipe needs to be, okay? So we're gonna denote this length L, all right? And what do we really have here, guys? Well, we have a right triangle, right? With our hypotenuse being the length of this pipe. And we're given two values. We're given the value of the angle and the value of one side. And we know that based on what we talked about earlier, the conceptual part, we can find this hypotenuse just based on those two values given. So that's pretty neat. So what are we going to use though? Well, we have the adjacent side and the hypotenuse. Okay, so that's ka, right? So let's kind of do that. So cosine, right, of 9 degrees equals the adjacent 500 over 500 yards. Let's write that out, yards, over the length, which is the hypotenuse L. Okay, well, let's do a little algebra here and just rearrange this, right? We're going to bring the L over, and then we're going to divide by cosine of 9. So L, if we swap this around, really is just equal to, let's see, L and then 500 yards divided by cosine of 9 degrees, right? Which is going to equal, come over here to the calculator, 500 divided by the cosine of 9 equals 506.23 yards. Okay, and that's our final answer, guys. So based on just two values given, we have our 9 degrees and our adjacent side, or our x side, being 500 yards, we were able to find the length of pipe that he needs, which is 506.23 yards of pipe, okay? So pretty simple, pretty easy, pretty simple algebra too. But I kind of want to challenge you guys and give you a hint of what we're going to talk about in our next video here. What if we wanted to find the angle if we were given two sides? So what I wrote down here is, how do I find the angle of a triangle given the values of its side lengths and not the angle? Okay, so let's say that we were given this 506.23, right? And we were given 500, but we wanted to find this angle. Well, could we do it? Well, if you stick around and watch my next video coming out, it's going to be on inverse trig functions, or trigonometric functions, okay? And we're going to be talking about kind of the inverse of the sine, cosine, and tangent, and what that actually means, and how we can find this theta here, or this angle, based on just side lengths. And that's a pretty useful tool as well moving forward. So hey guys, hopefully this video was insightful. You got a little bit out of it. If you did, like it, subscribe, drop a comment down below, maybe share it with a friend. But until next time, enjoy it. Math is awesome. And thanks for watching.